Hi everyone, and this is Alkenes and Alkynes, a follow-up to our branch chain alkanes yesterday. If you have branch chain alkanes under your belt and you're feeling comfortable, this really will be a no-problem lesson. So alkanes had a general formula of CnH2n plus 2. So every time you make a new bond, for instance, two H's, two C's becoming a double bond C, you have to get rid of H's to be able to do that. Because remember the rule about having only 4 bonds. So for instance, if I had, I'm going to lose that. Okay, do over. So let's say I had this compound that I've just drawn in the middle here for you. If I wanted to put a double bond in here, I can't do that without getting rid of some H's, because now each carbon has 5 bonds instead of 4. So each of the carbons involved here, oh, nice erasing. Oh, another great job. So each of the carbons involved in making the double bond, they each have to lose a hydrogen. So instead of being CnH2n plus 2, I get rid of that plus 2 because I don't need those 2 extra electrons anymore. So the way this formula works then is, let's say that I had C7, if I had 7 carbons, this formula just tells me how many hydrogens I would need. So it's H2n, so if n is 7, 2 n's is 14, for instance. All right, so naming, really similar to alkanes, so there's not too much new here, but we are going to change the ending to an -ene ending so that we can tell there's a double bond. The other thing we're going to do is we're going to number where the -ene goes. So right in front of the parent chain, when we see a number, it's telling us where to put the double bond. The little joke here, maybe you'll get it, maybe you won't. Before the exam, the person looks pretty cute, looks pretty good. This is using that short form of endpoints being carbons, and the ring is actually something we'll get into next week. And then after the organic exam, I'm diene, get it? There's 2 enes, 2 double bonds, diene. Okay, anyways, nerd humor. The C double bond C is the most important part of our carbon chain now. So when it comes to numbering our parent chain now, usually it's substituents that we give the lowest priority to. We try to give them the lowest numbers. That has now been bumped down. They're now second best. The double bond is now the first best, so we are going to give it the lowest possible number. So if the double bond is closer to the left, we number from the left, regardless of what substituents are doing. Double bond's closer to the right, we number from the right, regardless of what substituents are doing. So let's try some examples on for size. I'm going to get you to draw one first. So we're going to draw a 2-methyl 3-hexene. So again, we're going to start with this parent chain. Hex means 6 carbons. Ene means double bond. So there's not double bonds everywhere. The double bond is only going to be, pardon me, in the number 3 location. So let's start with our carbon chain, 6 in a row. 1, 2, 3, 4, 5, 6. I'm still just doing single bonds here, but now I'm going to put in the 3rd location that double bond. So I'm numbering from the left-hand side. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6. I always give you the lowest number, so I'm going to tell you to start drawing the double bond on the 3rd, and it's going to go towards the 4th. So 3 says start on the 3, go towards 4. Now let's put in our substituent. We've got a methyl. Meth means 1 carbon big. While tells me it's a side chain. And it's going on the number 2 location. So on the number 2 location, let's put in 1 carbon. As usual at this point, I'm grabbing from my bucket full of H's. Everybody gets 4 bonds. So let's put them in next. And there we go. Let's try another one. So this one I've drawn and I want you to name. Rules still apply, so we're going to find the longest carbon chain in a row. And as usual, or as most common, is straight through the center. So by circling it, we can see the substituents more obviously. Let's number our parent chain. We are going to number from the the right-hand side here, because we want to get to that double bond the quickest. So even though we have substituents hanging out way to the left, remember our rule, the double bond gets priority. It's the most important thing now, so it gets the lowest possible number. So we've got 6 carbons, so we've got a hexene, and we've got 2 carbon chains, single carbon chains, hanging out on the number 5 location. So there's a methyl here and a methyl here. And over here, because it's a hex, that's our 6 carbons. Ene means we've got a double bond, and our location is number 1. Now, whenever we have a number 1, you don't actually have to include it. It's implied if you don't have any number that it would be a number 1, or that there would be no other options to put something. So I'm going to show you 2 ways we could write this. We can call it a 5,5 dimethyl, because we've got 2 methyl groups, 1 hexene. Again, remember that we're putting dashes between numbers and words. Or we can call it 5,5 dimethyl hexene with no number. And again, when I don't see a number 1, the 2 options are that it's implying the number 1 location. In this case, that's what it's doing. Or it can also be used if there's no other option, there's only one possible place to put something, they can also exclude numbers. So you'll see us exclude numbers sometimes, and this is a really good example of that. Let's have a look at alkynes. And alkynes are a triple bond. And similarly, when we talk about the general formula, the general formula for alkenes was CnH2n 2n straight. Now for alkynes, it's CnH2n minus 2. Let's have a look at why that would be. So let's assume we're starting with a double bond now. If I wanted to put a triple bond in, once again by doing that, I end up with too many bonds. So I'm going to have to get rid of 2 more H's. So that's where that minus 2 comes in here. When I'm working with alkynes, again, I'm just going to change the ending of the parent chain so that I know that I've got a triple bond somewhere. Just like in the examples with alkenes, the alkynes take priority. So if I have an alkyne, I'm going to give it the lowest possible number, and I'm going to put the number out in front of the parent chain. Let's give it a try. So let's draw a 4-ethyl 2-heptyne. Again, I'm going to start with the parent chain. Hept tells me I have 7 C's. Yne tells me I have a triple bond somewhere, and the 2 out in front tells me where to put it. So let's start with our 7 carbons in a row. 1, 2, 3, 4, 5, 6, 7. And on the second one, there's a triple bond. So 1, 2, I'm going to start counting from the left. And again, I tell you the lower of the 2 numbers, so it starts on 2, goes to 3. Then on the number 4, again, just numbering from the left, 1, 2, 3, 4, I've got an ethyl. Ethyl is 2 carbons big. You can put them down if you like. I usually put them sideways like this, but if you want to go down, that's fine. Just takes up a little more space. So I've got all the pieces here. Again, eth is 2 carbon substituent. Number 4 tells us where to put it. And at this point, I'm ready to put my H's in. So everybody gets 4 bonds. So I need 3 H's here. The carbon in the triple bond, they don't need any H's. They've got 4 bonds each. I need 1 over here. Coming down here, I need 2 and 3. 2, 2, and 3. All right, let's try this last example together of a triple bond. So the first rule, as always, is find the largest carbon chain. How many do you spot? There are, in fact, 7. You can go up or down on the end, but I made this one purposely tricky just to practice. If you stopped here, that wouldn't have been the longest chain. There's still branches up and down, so you have to go until you get to a dead end, and you can go up or down, it would be equivalent. When you're numbering this one, we're going to number from the right, because again, we have to get to that triple bond as quickly as we can. So there's my numbering system there. Let's put it together in our word now. So we have 7 carbons again, so we have a heptyne. Hept again means 7, yne means triple bond. The triple bond starts on the number 2 and goes to the number 3, so it is a 2-heptyne. And we have 2 substituents. They're both 1 carbon big, so we have 2 methyl groups. So we have a dimethyl. Pretty good spacing today. And we have them on the 4 and 6 position. So we have a 4,6 dimethyl 2-heptyne. So I've just loaded a worksheet for you to practice today, and there's alkanes, alkenes, and alkynes on there. And again, use the homework page if you want to request any homework take up.